Hi, I'm Jason Weiss,
And I'm Bert Galper.
and we're here to teach you kids how to perform a solid IR spectroscopy at the Shadyside Academy Science Lab.
The first step in performing a solid IR spectroscopy is to form a pellet for the background scan. To do this, obtain a mortar and a pestle and 2 bolts and a hex nut from the mortar next to the IR machine. Remove a small portion of potassium bromide and grind it using the pestle. Potassium bromide is used for the background scan because it is relatively transparent and light passes through it relatively easily. When it is finely ground, add the potassium bromide to the nut with a screw in it as shown. Only add enough potassium bromide to have a thin layer cover the bolt.
To create the disc-shaped pellet for the IR scan, you tighten the first bolt until it is halfway into the nut. After pouring the thin layer of KBR into the nut, tighten the second bolt on top, squeezing the KBR powder into a very thin, semi-transparent disc. Before trying to further tighten the bolts down, you must secure the nut to the right table clamp. Once this is done, place the torque wrench on the proper setting to begin tightening up the bolts. Using the righty-tighty and lefty-loosey rule, remember that when turning the wrench clockwise, the ratchets should hold. If not, rotate the ratchet adjuster on the top of the wrench as indicated to set it to the proper position for tightening or loosening the bolts. Once both sides have been tightened to a point where none of the girls in your class can turn the wrench any further, ask Landers to tighten it up some more.
Holy mother of shitburgers!
Then, wait about 30 seconds after the final turn before loosening the bolts. To loosen the bolts, simply rotate the adjuster on the top of the wrench the other direction and cautiously begin loosening the bolts to prevent the thin and fragile disc from breaking during the process. Now, instead of having to flip the nut for each bolt when tightening or loosening, we found that securing the nut to the end of the clamp allows you to reach both the top and bottom bolts with the torque wrench without having to resecure the nut after either bolt has been pulled out. Considering how fragile the disc is, multiple attempts might be necessary to obtain a sample that is both structurally sound and transparent enough for a successful IR scan, so try not to get too frustrated if it doesn't work out perfectly the first time. Once your background scan is complete, grind a small portion of the KBR with your sample, and then repeat the process of creating the disc for your final IR scan.
Follow the lovely directions.
Is it even on?
When you have successfully created your pellet, remove it from the table clamp and move it next to the IR machine. Turn on the computer for the IR machine and log into the program called Spectrum. If you happen to forget the username and password for the program, look down. Follow the instruction sheet below the keyboard if you need assistance. Be sure that your pellet is still firmly in the nut before you run either your background or sample scans. Insert the nut into the nook of the IR machine, close the lid, name your scan on the computer, and press Start. Once the scan is complete, click Accept to see your results and click the IR Search button to see if your product matches any of the IR charts available in the database. Note the correlations and double-click on the name of your product if you wish to overlay your spectra with the one from the database.